Today we are going to see elastic file system. That is another type of storage offered by Amazon, and it has a lot of features which resembles on-premise NFS systems or Samba Share. So let us go ahead and see what it offers and what it can do for us. So it forms the file storage services offered by the Amazon storage. We saw block already. We saw archival storage. We saw file object-based storage. And when we are talking about file storage, EFS is your answer for that. So these are the summarized features of EFS when we are talking about cloud-based file system. When you say seamless integration, you can integrate your EC2 instances, you can put it inside your VPC, you can have encryption configured on top of that, you can have different types of availability zones. I mean, you can have the EFS file system available in different availability zones. When you're talking about EBS, if you remember, it is availability zone specific, that is AC specific. Let us use that terminology to stop confusions. When we are talking about EFS, it can span across availability zones, but within the same region. So seamless integration is to multiple services, monitoring, security by VPC, security by encryption, and also in terms of EC2 instances, it can support. So all these services are nicely, smoothly integrated. You just have to run a few commands in your terminal, then you can start consuming this service. And it scales up and down automatically. You don't have to do anything on the storage like we do in EBS. If you put a 10 MB of data, you are going to be charged for 10 MB. If you're going to be putting 1 terabyte, you are going to be charged for that. And next day you come back to 5 terabyte, then of course you can go ahead with that. So it scales up and down automatically. The performance for that kind of storage is also scaling up and down. It is not just your size increases and decreases, the performance also increases and decreases, and you have an option to say that I want provisioned disk, that is provisioned IOPS, so that you will get consistent input-output speed in your EFS file system. And once again, it is a fully managed service. So whenever you hear that, the first thing that you need to get into your thinking is the installation, configuration, maintenance of updates, patches, security updates, all those things are done by Amazon. You don't have to touch anything. You just go ahead and consume it and don't have to worry about the management part of it. And we already talk about access across instances. So when you create an EFS file system, you can have multiple EC2 instances reading and writing to the same file system at the same time in real time. So the file lock mechanism or corruption avoidance, all those things are built into the file system itself. The NFS has those protocols, and you don't have to worry about doing anything of your own. So you can go ahead and configure 10 different machines in different availability zones, and they can all write to the same file system, and it is fantastic in that way. And we spoke about the consistent performance because you can configure provisioned IOPS as we saw in EBS volumes, so you can dial up your performance or dial down as and when you require. Low cost, well, when you compare the other storages that are in the same market, that is file-based storage in the cloud, managed services, security, EFS is quite comparative, I would say. If you just look at it as a separate storage without any reference point, it doesn't look cheap. But when you talk about a fully managed, secure, consistent performance and seamless integration, then the cost really becomes compelling to go ahead and use this service. Highly available and durable because this service is built on top of S3 once again. That is the 11 nines of durability is available in S3, and this service uses storage from S3 service. So it is once again a very highly and available and a durable service. And as I said earlier, you can have encryption by checking on the box by using Amazon keys, or you can have encryption by your own keys. And you can also use security groups, firewalls to see which instances can connect, whether you can connect your EFS through the internet or you don't want to allow anybody from the internet to connect. So those kind of firewall rules are also possible to secure your file system. So this is a simple architecture. If it is overwhelming, let us try to break it down, and that is what we are going to build now. The outermost rectangle that you see here is, think of it as an AWS region. Let us say for this scenario, let us talk about US Virginia region. And inside that, there is another bigger rectangle which is called as an availability zone. Let me try to highlight it now. So this is the availability zone. That is availability zone. Let us say that is called as US West 2A, and there is another availability zone called as US West 2C. This is just a representational picture. Might be the same thing in the real region, might not. So this region has two availability zones, and inside those two availability zones, I have two servers. In this case, I have started a T2 micro, and in these T2 micros, I have another EFS file systems accessible here and here. So what is happening here is this EFS file system sits outside your availability zones, if you notice it, and it sits inside the region. So it is not available outside the region, but all of those AZs can access it by using a mount point. So you need to make sure you create a mount point in whichever availability zone you want to access the EFS, and then you can configure your server to talk to it. And most importantly, this is the first thing, let us say, creating the mount point. And second thing is you need to ensure that your firewalls are allowing this port. We are going to use NFS version 4. NFS is a network file system protocol, and that package is built in. This entire EFS file system is built using this NFS packages, and your Linux machines also need to have this NFS package installed. If you're using Amazon Linux, they come pre-installed with some version. If not, you will have to go ahead and install. Another caveat here is Windows cannot be used for along with NFS because you need to install Samba Share or something called as a CAFS. Then also it doesn't mount directly. That is, you cannot use NFS directly in Windows. So only Linux machines can use EFS at this moment. So with those caveats out of the way, so first thing is create your mount point, ensure that you have enabled your ports, and then go ahead and mount them in your Linux servers. Just like you are mounting an EBS volume, you create a mount point and then you put in your device name, and then instead of device name here you will give the NFS mount point name and then the directory. You should be able to start reading in files. So this is the demo we are going to build. We are going to create an EFS. We are going to create a couple of servers, and then we are going to write something from server A, let us say, and then we are going to see whether we can modify it from server B. So because it is going to happen in real time, and all those commit and transactions will be visible from B also. So if we do something from B, and it should be visible in A as well. So let us go ahead and build this demo in a short while. Before that, I wanted to share some of the use cases when people really use these kind of file systems. The one common use case is content repositories. Let us say you have a group of developers and all of them want to access the same website they're building. So that one person might be building the home page, another person might be building the home page images, and then another person building the CSS, style sheets, HTML pages. So all of them, all the elements come together to create the web page. So they need to have the same content repository, and they have to access the latest files of everybody's creation. So in those cases, EFS file system makes a fantastic use case. So the same thing goes for, we saw about this content repositories and for development environment. The other use case is, let us say you have corporate how-to documents, and all your employees want to access those how-to documents. Then in those cases, you put in all the files because these are static files, not going to change much. And then you configure access for all your employees as a shared drive, and then you can go ahead and browse them anytime, or configure a website also on top of it, like say static website using S3 buckets. So that is also possible. So that is the two use cases. Next one is home directories. Let us say you create, your employees have roaming profiles, and every day they start up a new server. Then their home directory, which is created on top of this EFS file system, will be auto mounted whenever they start a new machine, and they can need not worry about my desk is here, my laptop is here, my desktop is here, because their home directory is going to get mounted wherever they log in from, and they will have access to all the files that they did yesterday or previous time and they logged into their machines. So that is another use case. And in a server level or data center level, people use that for big data clustering, because all the data needs to be in one place for quite a lot of big data analysis. And EFS being a scalable and high performance storage, people configure their backend with big data. And web server farms wherever batch processing or kind of data processing happens. EFS becomes a fantastic use case for that. So these are the common use cases. If your customers ask for these use cases, then you can recommend EFS as one of the solutions for them. So let us go to our dashboard and see how we can set it up.
We are still seeing the PPT. We are not.
So here the first thing is go ahead and create a file system, and it is going to ask you which VPC. If you have an older account, multiple VPCs will be there. If you are in production, you're going to choose the production one. For a demo, you can go ahead and quite easily choose the default one, which solves a lot of problems with security groups and subnets, because that is all pre-done for you. So here in Virginia, as you can see here, there are 6 availability zones all the way from 1A to 1F. So if you check all these marks, that means that my mount point is going to get created on all these availability zones. Let us say I don't want in all of them. I just want it in, let us say 1A, 1C, and then let us say 1E. I just want to skip one of them. And it is giving me a choice of, if there are multiple subnets, it will give me a choice here, which subnet I want to give. And then if you want your EFS to be available only in a particular IP address, you don't want that IP address to change, then you can go ahead and hard code your IP address in this place, assuming you know that what IP address is configured here. But this is again for more secure configurations. You can just leave it as default and still it will be working. And again, make a note of the security group. If our EFS ports are not working, we'll go ahead and change this. So by default, whatever security group allocated with this subnet will be picked up automatically here. And if you want to add some more, then you can go ahead and add it. But if you're choosing the default VPC, this will be picked up for you automatically. So go ahead and choose next step. And I'm just going to give a name. I'm just going to say EFS demo, and then I'm just going to say owner, then say Mystique. And then here is the part where I said you can choose your performance of how much performance you need. So of course there is a minor changes in cost when you choose this one. There is a different cost when you choose this one. The provisioned IOPS cost comes into the picture. So let us choose default here, and whether you want to enable encryption or not. When I choose this, Amazon is going to give me all the keys that are in my account, which can be used with EFS. So that is what is listed here. And if you want to use encryption key from some other account, I need to just mention the AR and ID here. If you remember, it is Amazon resource number. Almost every resource that you create in Amazon will have an unique identifier, and we can put it here. In this case, that will be the key ID. So let us not do encryption. Let's just go ahead and build it. And it is asking us to review the configuration, and click on create file system. Just a couple of clicks, you are done with your file system. And once again, it is going to take the request, and since it is a highly scalable and quite complex configuration, it's going to take a moment to get it configured. It has just taken the request, and if I scroll down here, and you can see here the lifecycle state is mentioned as creating. It is going to do the background processing meanwhile and get it all set up and ready in a few moments. Meanwhile, Amazon also gives you a recommendation for people who might not be familiar on how to mount an EFS file system. There is a set of instructions that are given here. If you click on that, Amazon will give you the commands that you need to run for mounting your file systems in your Linux machines. So as you can see here, the commands are given. If you are using Amazon Red Hat Linux, it just says that you need to run this command to install the NFS utils package. And if you're in Ubuntu, you need to do this. And after then you log into your, then you need to log into your other instances. Go ahead and create the file system and mount it. So all I am also going to do is just copy paste these commands after creating my servers. So let us go ahead and create 3 EC2 instances, and let us go ahead and connect to them as well. When you're creating your instances, ensure that you are choosing the same default VPC where you have created your EFS file systems also, and choose the same subnets where your EFS file systems are going to create a mount point. So if you remember, I created for 1A and 1C and 1E. So let us just go ahead and confirm that. So I'm going to start my first server in 1A, and I need a public IP address so I can connect to it. So I'm just going to click on that next. So let us go ahead and do that quickly now. Here is another important bit. Ensure that you're putting the server also into the same security group where your EFS was also created. If you are not sure, just take a note of this number, SG group 04 blah blah blah, and then go here, and in your mount point also it will be listed somewhere. If not, let us go ahead and find it out. So here are my three servers, server 1A, 1C and 1E, all of them booting up. So let us go ahead and connect to them, and we will start installing the packages as recommended by Amazon. So we have all the three servers up and running, and we also have terminal sessions connected to them to ready to execute commands to mount your EFS file system. So let us go back to our EFS and see there. So in my status, my EFS says the lifecycle state is available, so we are good to mount it. And this is the mount point through which I can access my EFS file system. So if you go ahead and click on EC2 mount instructions, Amazon gives you all the commands. And since we are running in Red Hat Linux, I'm going to install these packages in all those terminals now. So let us go ahead and do that. Multi-paste. So it is installed, pasted. Just press enter. So it is going to get installed in all of those three servers that we have created: server 1A, 1B, and server 1C and 1E. So let us give it a minute for it to install. Then we will go ahead and do the next one. So two servers have completed, just waiting for the last one. Seems to be a bit slow for some reason. So meanwhile, while the server is getting its packages built and up and running, I'll just go ahead and create the mount points on the other two servers. So we created the mount point, and the final step is going ahead and mounting this EFS itself. And remember, only when your security group is allowing the ports 2049, you will be able to mount it successfully. Otherwise, it is just going to hang there, and it's going to wait for the network connection to happen. So the other server is almost completed. Let me just wait for a moment. And before that, what I'm going to do is I'm just going to show df-h and see what are the current file systems that are there. So you can see here there is no file system at the end. So I'm just going to say let me just paste it on this guy alone and create it. Okay, so the final step is going ahead and creating the mount point itself. Let me clear the screen, paste this command. Oh, great. I need to do multi-paste. Okay, let us do paste. So if I execute this command now, and if my ports are working, it will automatically mount it. And if you're seeing that if our prompt is hanging like this, and it's almost guaranteed that your security group is not allowing the 2049 port, which is required for NFS to work. So what I'm going to do now is I'm just going to head over to my EC2 dashboard, and then go ahead, and here, where is my security group? Here it says that default, and if you click on view inbound rules, it is going to list you what are the rules that are currently available. And you can see here the 2049 port is not there. So I want to modify this. So I'm just going to click on default, and it's opening the security groups in another tab. And I'm just going to add that as well. And if you come to inbound, you can see there are two ports only allowed. That is port 22 for me to connect, and port 80 if there is a web server running. So I'm just going to say NFS here, and automatically it will pick up the port number, so you don't have to know anything. And what I'm going to say is this connection is not going to come from outside. Only all my three servers are going to talk to each other. So I'm just going to give the security group ID itself. So SG. So all connections originating from this security group will be allowed. Come on, I'm not able to click on this. Okay, let me type that. 04755F7B and click on save. Come on, for some reason. Okay, I somehow managed to do that. So now that my port is enabled, if I go ahead and try to mount it again, it should work. Oh, multi-part. So here it is pasted in only one server, so I'm just going to paste it in the other two servers as well. So mounted there. Third one. So if I do df-h now, I should be able to see a new file system now. You can see here at the end, a new file system is created. Let me exit multi-execution. So let us focus on one server at a time. So you can see here, this is the mount point of my file system and its size is of about 8 exabytes and it is mounted under the root EFS file system. So I'm just going to go into this file system now. Let me execute it properly. And let us say I'm creating a file. Oh, I'm sorry. Touch file 1, 2, and 3, 4. So if I do ls-l, all these files will be created. And if I go here in my directory 2 and do ls-l, I will be able to see all these files. So let us say I want to write something. I'm just writing something to my file 1 now. And there is only a single line here. So I'm just going to go ahead and execute this one here in the third server now. So go ahead and open the file. You see here the content is available here to be modified. So that is how you mount an EFS file system on different availability zones and access them from different servers, and all of them can read and write to the same file system in real time. It's really fast, really scalable, and very convenient for distributing content. If you're having any difficulties, let me know. I can help you with that.